So we are going to talk about sine and cosine. All of our trig functions are what we call periodic functions. That means they repeat after a certain amount of time. That length of time it takes to repeat is the period. So when we're talking about the graphs, a lot of times I'm going to say, okay, what's the period of this function? And that just means how long does it take until it repeats? It's like a wave. It's just the same thing over and over and over again. And if we think about sine and cosine, we might be able to figure out already how long it's going to take to repeat. Think about your unit circle. What happens once you get all the way around the circle? And then we have all the same values again, right? We can go around the circle as many times as we want. And so we've already used this fact when we were talking about coterminal angles. We're doing everything in radians, so sine and cosine are periodic, and the period, the amount of time it takes before they repeat themselves, is 2 pi. So let's go to our little handout, and we're going to figure out what the graph of sine looks like. Right, so just like anything else, if you don't know what the graph looks like, in algebra, every time we graph something, we would make a t-chart to figure out what our graph looks like. So that's essentially what we're doing here. I did give you kind of a chart already. It doesn't have every single point, so there's certainly more we could put on here. I just did a few major ones. These are the ones that we are going to use when we sketch our graph from here on out. Now, if we need to put in some more today so we can figure out what it looks like, then we will. So we are going to figure out the sine of each of these. So these points on my x-axis are going to represent each quadrant. So if you think about that circle when we went around, we started at 0. 90 was pi over 2. That was pi. 3 pi over 2. And then back to the beginning is 2 pi. So I'm basically taking my circle and unwinding it and seeing what these values are. All right, so let's think about this. The sine of 0. So if we think about our unit circle. And the marks here. All right, and this was the point 1, 0 on our unit circle, right? Sine is the y, so sine of 0 is 0. At pi over 2, the point on the circle was 0, 1. So, what's the value of sine of pi over 2? What's sine here? 1. So at pi over 2, we're at 1. Okay. This is the point. We have 1, 0. What's the value of sine then at pi? All right, this is 0, -1. So at 3 pi over 2, sine is -1. And at 2 pi, we're back to where we started, so sine is 0. All right, I don't know what's going on with my board. This is going to be really annoying now. Okay. So, this kind of gives us an idea. It's maybe not fully clear yet. We could plot more points if we needed to, especially this first time. Now, after we graph it today, we'll kind of know what it looks like. If I put in some other points, right in the middle of 0 and pi over 2 is pi over 4, or 45 degrees. What's the sine of 45 degrees?
Square root 2/2.
What is that in decimal form?
.7071.
Okay, so halfway here we're at 0.7. So we can see it's not just like a straight line here. Okay, it's actually curved. And we can plot the other points we wanted, you know, at 30 degrees we're at a half, and we're here, and then we're here. So what it is actually a curve. When you draw this graph, I am going to be making sure it's not a zigzag, okay? Those are not sharp corners. It's just a nice, smooth curve. And then the graph doesn't really end at 2 pi because you could keep going around the circle. So what it does is it just keeps repeating. And it could go either direction because you could be going around the circle backwards or forwards. So it's just going to continue on. The domain of this, is there any x value we can't hit if it keeps going both directions? No, it'll go everywhere. You can just keep going around your circle. So our domain is negative infinity to positive infinity. The range is the y values. What y values does sine hit?
Or -1.
So it's from -1 to +1 with a bracket. And we could fill in this t chart up here. These are just the points that we put in. And we know we could do more. This is what the graph would look like if you put every point on the circle and they would just fall along this curve. Is that okay? All right, this is just showing you what 2 periods of sine would look like. So we graphed 1 period, 1 time around the circle. This just shows 2 times around the circle. And we could have as many of these as we wanted. It just keeps going forever. So let's do cosine. So again, we're going to think about the circle, and we're going to think about our quadrants. So this high point is 1, the low point is -1. This is my 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right, what is the cosine of 0? Cosine is the x. 1. It starts up here. At pi over 2, cosine is 0. At pi, it's -1. 3 pi over 2 is 0, and 2 pi, we're back to 1. Okay. Again, do you think this is like a zigzag back and forth? No, this is curved. So these are not little line segments. It's a nice curve. And that would be more obvious if we put more points on here, which we could certainly do. I'm just trying to show you the minimum, which points we have to have. That graph is slightly lopsided, but hopefully you get the idea there. Domain. Just like summing, this keeps going forever, so our domain is everything. The range, what's our range?
-1 to 1.
Which we actually talked about this back in chapter 1 when we defined our trig functions. We can also think about it on the circle. You know, cosine is your x value on the unit circle. The smallest x is -1, the biggest x is +1. Sine is your y on the circle. The smallest y is -1, the biggest y is +1. So we could think about it a couple different ways. Is this okay? All right, so these are the key points that we are going to use when we graph our trig functions. And this just shows you what 2 periods of cosine look like. It is very similar to the sine graph. The only difference is sine starts at 0 and cosine starts at 1. But they both have the same wave pattern going back and forth because they both just oscillate between -1 and +1. Even or odd? That's an algebra term. Remember, even means symmetric to the y-axis, and odd meant symmetric to the origin. So if I want to think about the symmetry of these, let's look back. We'll go to sine first. Let's look at this one. So this vertical line represents my y-axis. Is sine symmetric across the y-axis? If I flip it over the y-axis, does it overlap itself? No. Is it symmetric to the origin, which means you flip it over the y and over the x? If you do 2 flips, it overlaps. So sine is what we call an odd function. In algebra, when we talk about odd functions, it meant if you put in a negative x, it made your y negative. So this was the definition we had in algebra. We will talk about this more later on, but this is going to be really useful. With sine, if you have a negative on your x value, you can actually just pull it out in front of your trig function because of this property. So cosine, is it even or odd?
Even.
Even. Cosine is symmetric to the y-axis. Okay, that means, if you think about this graph, whether your x is positive or negative, you get the exact same y value. So in algebra, when we talked about it, we said, well, that means if your x is negative, it's the same as the positive. So with cosine, if it has a negative on the angle, we'll actually just be able to drop it. So this is the really important thing that we will come back and reference every now and then when we're going through these graphs. So let's start looking at some variations of these graphs. I want to graph y equals 2 sine x and compare it to the graph of sine x. So technically these graphs go forever, so you could draw any interval you want. We're going to usually go 0 to 2 pi because that's all the way around the circle. So this, remember the distance on the x-axis, these represent the quadrants, so it should be equally spaced. So the same distance between 0 and pi over 2 as there is between pi over 2 and pi and 3 pi over 2, and 3 pi over 2 and 2 pi. So we actually do 5 total points because you have to have your starting and ending point on there. I'm going to graph sine first, just to refresh. So the actual sine graph that we already saw. Okay, we said sine of 0 was 0. Sine of pi over 2 was 1. And then it just keeps following the pattern. Back to 0, -1, and 2 pi is where you started. And I'm going to make this dash because it's not my final one. I just want to compare it. So this is what sine normally looks like. going to do 2 sin x. So this just means 2 times the sine of whatever angle. So what is the sine of 0? Come on, sine of 0 is 0 times 2 is still
0.
0. Okay, pi over 2. The sine of pi over 2, or the sine of 90 degrees, is 1 times 2 gives us 2. So pi over 2, we get 2. The sine of pi is 0 times 2 is still 0. At 3 pi over 2, sine was negative 1 times 2 is negative 2. And at 2 pi, you're back to 0. So here's my sine, 2 sine of x. Alright, so what did the 2 do?
It got longer.
It made it get
Height-wise.
taller. Yeah, it stretched it. Think back to algebra. When you took something, when you put a 2 in front, wasn't that a vertical stretch by 2? Multiplying your y's times 2, it's the same transformation here. In terms of our trig functions, we actually give that a name. That's what's called the amplitude of our function, or the height. You talk about amplitude a lot when you're looking at waves, and sine and cosine are like waves. So the amplitude or the height of this graph is 2. So why don't you guys see if you can figure out what 1/2 cosine would look like. So this black line represents the regular cosine that we've already graphed. So when I want 1/2 cosine x, all that's doing is multiplying by a half. So when I ask you for cosine of 0, you can do the hand trick, you can think about the unit circle. You could look right here. Cosine of 0 was 1. So 1 times a half is 1/2. At pi over 2, cosine was 0 times a half is still 0. At pi, cosine was negative 1 times a half is negative 1/2. 3 pi over 2 is 0, and 2 pi is 1/2. So what did the 1/2 do to my graph? Shrink it. Isn't that what we would have expected based on algebra transformations? Okay, so it's the same thing here. Except we call that the amplitude. This pink graph that I drew has an amplitude or a height
Of
1/2. So the amplitude of a periodic function is half the distance between the maximum and minimum. Okay, it goes from negative 1/2 to positive 1/2. So the amplitude is basically your height from the center. Center is the middle. How far above and below that do you go? In our trig functions, when we have the amplitude is just your coefficient. Okay, it's that coefficient in front. Tells us how much we're stretching or shrinking our graph. One thing when we're talking about the amplitude, it's a height, so it's always positive. So if I ask you the amplitude, you need to give me a positive number. If there were a negative in front, what does that negative do to your graph? Flips it. Okay, so that's a different kind of transformation, but the actual amplitude is just the positive number we see in front. say y equals sine 2x. And I want to compare that to regular sine. So regular sine, I'm going to go ahead and draw as a dashed line here. We know it has a height of 1 and -1. 0. Sine starts at 0 and then goes up. So that's what sine looks like. I want the sine of 2x. Okay, if I put in 0, 2 times 0 is 0, so we get the sine of 0, which is 0. So we're still getting that point. If I put in pi over 2, 2 times pi over 2 is pi. The sine of pi, if I look at this graph, it was 0. If I put in pi, I get the sine of 2 pi, which 2 pi sine is 0. If I put in 3 pi over 2, 2 times 3 pi over 2 is 3 pi. That's coterminal with pi, and sine was 0. If I put in 2 pi, 2 times 2 pi is 4 pi, and sine of 4 pi would be 0. Does this mean that it's just a flat line? Probably not. Let's try some different points. What's halfway in between 0 and pi over 2? Pi over 2 is 90. What's halfway in between 0 and 90? 45. So pi over 4. If I put in pi over 4, 2 times pi over 4 is pi over 2. Sine of pi over 2 is 1. So in the middle here is where I hit my 1. So what do you think it's going to be halfway in between pi over 2 and pi? That's sending my negative 1. Okay, then we'll be back up to positive 1. Back down to negative 1. So what did that 2 make my graph do?
Horizontal shrink.
Yeah, horizontal shrink. How many periods of my graph did I just draw? A period is how long it takes until it repeats. So I see, here's a complete cycle. I'm back to where I started. And there's another one. So if I put a 3 there, how many periods do you think I would have gotten in that section? 3. So a number with the x changes, it's like a horizontal stretching or shrinking in algebra. And it's the same thing here, but another way we talk about it is it adjusts the period, how long it takes until our graph repeats. So if you have a number with your x, it will change the period, the amount of time it takes to repeat. Our graph, we had a 2, and if you saw, once we got to pi, it started repeating. So the period is 2 pi divided by b. 2 pi is your normal period. You divide it by whatever x is multiplied with, and that will tell you how long it will take until your graph starts to repeat itself. the steps we're going to go through. When we graph these trig functions, transformations from algebra work, but it can sometimes get complicated. So we're going to use those same ideas, but we're going to use trig terms to talk about it. So first thing we'll do is always list the amplitude. Then we'll list the period. Third step is to decide what to count by. And then the fourth step is to plot our points and graph it. So, step 1, amplitude. So if you're writing this down, you don't want to write every word. What I would write is step 1, amplitude, step 2, period, step 3, count by, step 4, sketch. You just want a one word for what to do at each step. So let's see if we can maybe graph a couple of these for the end of class today. So I want to graph this over 2 periods. So we could do it by making a t-chart, but we kind of saw in the last example, it was a little annoying because when we just plugged in our regular points, we kept getting 0 and then we had to figure out what else to plug in. If you use the method that I give you, then it's going to be a lot easier to draw these graphs. So step 1, I want the amplitude. Where do you find your amplitude? Number in front, so that's just 2. Step 2 is period. Period is 2 pi divided by the number in front of x, which is 3. Third step, we're going to find what I call the count by. These are going to be the points on the x-axis. So what I know right now is if I start this at 0, when I get to 2 pi over 3, it's going to start repeating itself. Okay, I need to know what are those main points in there that represent like my quadrant breaks. So how many quadrants are there? 4. So to find it, you will take your period and divide it by 4. So the length of my graph divided into the 4 quadrants. When you do that, you can use a calculator, just don't put in the pi. So do like 2/3 divided by 4 and then give it back to me as a fraction.
1/6.
So we're going to count by pi over 6. So my graph. We're starting at 0. My high point is going to be 2 because that's my amplitude. And my low point is going to be -2. Okay, my first point is 0. We need a total of 5 points here for one cycle. We have our starting and then 4 more. To get those points, we use our count by. So if we're at 0 and we add pi over 6, we're now at pi over 6. And we keep adding that pi over 6 to get all the other points. So pi over 6 plus pi over 6.
2 pi over 6 or 1/3.
So 2 pi over 6 plus pi over 6.
Pi over 2.
Right, 3 pi over 6, which reduces to pi over 2. 3 pi over 6 plus pi over 6 is 4 pi over 6, or
2 pi over 3.
notice, where did we see 2 pi over 3 before?
And
Yeah, 2 pi over 3 was my period, and that is my 5th point. So we're doing good so far. All right. Sine. So think about the graph. You've got that picture in front of you where we drew our nice graph. The graph of sine starts at 0 and goes up. Okay, when you start on your circle, sine is always 0. So at my first x value point, we're at 0. At my next one, I should be at my high point, which is 2. And then it's just going to bounce back and forth between my 2, 0, and negative 2. So then it comes back down to 0. Pi over 2 would be at negative 2. 2 pi over 3 would be at back to 0. Could you get these points by plugging those values into your trig function? Yeah, that's all we're doing. We're just saving time by using the pattern we know. You know, if I put pi over 2 in, I get sine of 3 pi over 2, which we know is negative 1. 2 times negative 1 is negative 2. That's where it comes from. We're just using the pattern instead of making the t-chart every time. So there's my graph. But what did I ask in the question?
Over 2 periods.
2 periods.
So you gotta do it.
Yes. So to get the second period, we have 2 options. It could go in the positive or the negative direction, right? We know this thing really keeps going forever. The easiest option would just be to pick up where we left off. This is the first point of that second period, so we really just need 4 more points. And we keep adding our count by. So 2 pi over 3, that was 4 pi over 6, plus 1 pi over 6 is 5 pi over 6. 5 pi over 6 plus pi over 6 is 6 pi over 6, or pi. 6 pi over 6 plus pi over 6 is 7 pi over 6. 7 pi over 6 plus pi over 6 is 8 pi over 6, or 4 pi over 3. And we continue our pattern. So we're at 0, so we go up to our high point,
Back to 0.
to 0, down to the
Negative 2. And then back to 0.
What if I asked you for a third period? Yep. Just keep adding pi over 6 for 4 more points.
You can go the other way.
Yes, if you go the other way, you would be subtracting your count by, because you'd be going in the negative direction. All right, what questions do you have? Let's try to do one more real quick. Let's just do 1 period on this one since we're kind of running low on time. Okay. Amplitude. Okay, we have to watch on this one. What do you notice when you look at this equation?
There's a negative.
There's a negative. Go back to where we talked about even and odd. Sine was even or odd? Odd, which means if you have a negative, you can pull it out in front. So this is a negative 3 sine x over 2. I'm just going to write that as 1/2 x. So I pulled the negative out in front. So my amplitude is still the number in front, which is positive 3. What would that negative do to my graph?
That would flip it over.
Right. Okay. My period is 2 pi divided by the number in front of x, which is 1/2. So 2 divided by 1/2,
Pi.
4. If you flip and multiply.
Oh yeah.
How do we find the count by?
You take the period and then divide it by 4.
4. So 4 quadrants. So we get pi. The amplitude is 3. So we'll have to make sure our highest y value is 3 and the lowest is negative 3. We're counting by pi. So 0 is my first point. 1 pi. 2 pi. 3 pi. 4 pi. And try to make sure those are spaced evenly as best you can. Okay, so in algebra, when we flipped, we would always draw the original and then reflect it. We're trying to make our graphs as simple as possible, so not drawing parent functions and transformations per se. We know that sine starts at 0. And then where does it go after that? It goes up, right? But if we're flipping,
It's gonna go down.
it will go down. So then we'll go down to -3. Back to 0.
Up.
Up to +3.
Back to 0.
Any questions here? So, we are not quite done with this section. I definitely want to do one more where we graph a cosine, but we only have 3 minutes, so we'll do that tomorrow. And then a couple where we look at a graph and write an equation. So, I'm going to go ahead and give you this assignment. This is the entire section, but we're not done with it, so it will be due on Monday. Tomorrow I will wrap up this section, and I'm going to do a little bit out of the next section. I will probably put a few of those problems. So basically, today, Friday, and Monday, I'm going to cover 2 sections for you. So tomorrow we'll do a little bit out of each. So if you're going to be gone tomorrow, make sure you watch the video to get those last bit of notes and the new problem.